Yes, I welcome you all for another presentation on signals and systems, in which I am going to explain you about the same, I mean, the classification of signal, in which we have seen the various classifications of signals in the previous presentation, and we have been discussing about the standard definition of the signal. It is, by the way, module number 3, in which we have seen x of t is equal to a cos omega t is our standard form of the signal, and this is what from here what we are seeing is that omega is your angular frequency. Omega is nothing but your 2 pi f. It is radians per second basically, and then so from here this is angular frequency. Omega is equal to 2 pi f is very important relationship that you need to remember. And from here, what is f? F is the natural frequency or the normal frequency. F is equal to, it is omega by 2f. F is equal to hertz. This is measured in hertz. Okay, omega by 2 pi basically. And then from here, what is the time period? The time period of the signal. Time period is equal to t is equal to, it is 1 by f. This is equal to 1 by, what is your f? It is omega by 2 pi. If you take, it is nothing but 2 pi by omega t seconds. Okay, so 2 pi by omega. 2 pi by omega. This is what your time period, also sometimes called as the fundamental time period. The fundamental time period. So this is what the basic definition of this is a co-sinusoidal signal. So I have considered a co-sinusoidal signal, and for which I am defining you what is the angular frequency, what is the natural or normal frequency, and what is the time period of that signal, co-sinusoidal signal. And similarly, the same is applicable to sinusoidal signal also. That is nothing but a into sin omega t. You can write like that. Clear? Now we will see one particular example on periodic signal. So we will see about the first classification of the signal. Okay, the first one is periodic signal. Periodic signal. What is a periodic signal? What is a periodic signal? So any signal x of t, let us say x of t is any given continuous time signal. Let us say x of t is any continuous time signal. Then if this particular signal satisfies the condition x of t is equal to x of small t plus capital T. Okay, small t plus capital T. If it satisfies this condition, then the given signal x of t is said to be a periodic signal. Okay, for any given signal x of t, nothing but it is a continuous time signal. Okay, for any given continuous time signal x of t, if this signal satisfies the condition x of t is equal to x of t plus t, means that in the given signal we need to apply wherever t is there, we simply substitute t plus t. By substituting in place of t as t plus t, then you obtain one value. Some x of t plus t is equal to how much? That value should equal to your actual x of t. If it satisfies that condition, then the given signal x of t is called a periodic signal. If it does not satisfy, then the given signal is said to be an aperiodic signal or non-periodic signal. Non-periodic signal. Okay, in order to understand the concept of this, okay, periodic one, then I will explain you a simple example. Thereby you will understand very clearly about the concept of how to find out the, how to identify, how to determine the given signal as a periodic one, like that. I am considering one simple example. Let us consider a simple example as x of t is equal to, let us say, a cos omega t itself. Let us take this particular example itself. X of t is equal to a cos omega t. For this, my question is whether is it periodic one or a periodic one. Determine the periodic one or a periodic one, like that. So just how I can solve this? How I can solve this? Is it periodic? Is it periodic or not? Or not? What is this? This is my question. This is my question, right? This is the given equation already. I am taking it as directly as equation number 1. Okay, x of t is equal to a into cos omega t. This is given. Now, what I need to do, what is the condition that should satisfy for the signal is to be periodic one? Then the condition is that x of t is equal to x of small t plus capital T. This is my condition. This condition we must remember. X of t is equal to x of t plus t. This should satisfy this condition. Well, x of t is already given. This x of t is nothing but this one only, a cos omega t. Now, I need to find out what is x of t plus t. Then that is my question. So, x of small t plus capital T, how? Is nothing but in the given x of t, wherever t is there, you simply substitute t plus t. That's it. That is nothing but a cos omega into t is there, no? In t, you substitute t plus capital T. That is what actually this meaning. Here t is there already given. So in this particular t, I am considering as t plus t. This particular I am substituting. Then x of t plus t is nothing but a cos omega t plus t. That's it. Now simply you substitute further this. This becomes a cos omega, expand it. It is omega t plus omega into capital T. Clear? So this can further written as a into cos. Let us take omega t as some theta and it is some omega t. Like that you write. Consider let theta is equal to omega t. This particular omega t I am treating it as theta. Then you can write theta plus everything you write in bracket like this and consider this as theta and omega t. Right? Then furtherly that can be written as, that can be simplified as, I will write here. So that furtherly can be written as x of small t plus capital T is equal to, what is this? A cos theta, actually clear, that is theta. Omega, let it be there. What is t actually? Just now we have seen. T is equal to, what is that? 2 pi by omega. This is what your t, nothing but. Already you have t now. In this t, you substitute that 2 pi by omega. Then this omega will cancel out. Then you will have here a cos, it is theta plus simply 2 pi. It is nothing but cos of 2 pi plus theta. Cos of 2 pi plus theta. It is 2 into pi, nothing but how much? 2 into 180. Pi is equal to 180. Therefore, 2 into 180, it is a 360. Means cos 360 plus theta, cos theta. Cos theta means a into cos theta you will have, because since cos of 2 pi 360 plus theta is equal to, it becomes as cos theta itself as per our trigonometric relation. Therefore, it is nothing but a into cos. What is your theta? Theta is nothing but omega t. This is what your x of t plus t. Clear? Now you can call it as some equation number 2. This you can call it as your equation number 2. Now equate, see your x of t and then this is x of t plus t. Both are same. So therefore, what is your x of t? X of t is equal to a cos omega t. Therefore, x of t is a cos omega t. Then what is x of t plus t? A cos omega t. Therefore, both are equal. Therefore, both are equal. That means your x of t is equal to x of t plus capital T. Therefore, both are same. Both are equal. Hence, a cos omega t is called a periodic signal. It is called a periodic signal. Likewise, we need to find out the given signal, whether it is a periodic signal or otherwise. If it does not meet that x of t value, if it does not equal to x of t plus t, then simply you can say that the given signal is a aperiodic signal. It is a aperiodic, non-periodic signal, right? And then let us see one more simple example on this. Let us see one more simple example on this. Another example I will explain you. Very, very interesting one this is. So, the given signal x of t is equal to, it is sine 2t. Sine 2t. This is the given signal. So, determine whether the signal is a periodic signal. If so, find out what is the fundamental time period of this signal. Okay. Determine whether it is a periodic one. If it is so, then what is the time period of this? How we can calculate this? Very simple. You can call the given as equation 1. Whenever the problem whenever the problem is given like this, and in this they will ask you to find out the time period of the signal. Sometimes it will be asked in GATE examinations, even IAS examinations also. They will give you the signal like this, find out the fundamental time period. So for that, what you need to do is that what is the given signal? Is it sinusoidal signal or cosinusoidal signal? If it is the sinusoidal signal, then the given problem must be equal to the standard form of the sinusoidal signal. You must equal. Means that what is the definition of actual sinusoidal signal? That is x of t is equal to actually a sin omega t. Clear? This is what my actual definition of a sinusoidal signal. This is the standard form of definition of sinusoidal signal. So the problem is given on sinusoidal, then you must consider the standard form of the definition of sinusoidal signal. That is nothing but a sin omega t. Now you compare this sin 2t with this sin omega t. So given problem must be equal to with the standard form of the definition. Clear? Then this is equal to what you will get, sin 2t is equal to a sin omega t. Clear? So in finding of the fundamental time period, the magnitudes need not to be considered. Means here a is not required to consider a. I will remove that actually. So magnitude is not the important parameter, not to be considered actually. You remove that, you ignore that, not required. So only sinusoidal, the sign nature of the signal with the remaining quantity other than magnitude you have to consider. Means sin 2t is equal to sin omega t. That's it. You consider that much only. So equal these two. You ignore the magnitude part, not required to consider. Then sin 2t is equal to sin omega t. So if you equal these two, so both sides sin will cancel out. What will remain here? It is 2 times t is equal to what? Omega t. Clear? So again t will cancel. Then what is this actually? 2 is equal to omega. Then omega is equal to what? What is omega? It is 2 pi f is equal to 2. Clear? Then both 2 will cancel out. Then f is equal to what? 1 by pi. This is your natural frequency. And then from this, what is time period? It is 1 by f. This is nothing but 1 by pi. This is nothing but your pi. This is what the time period of the given signal, this sin 2t. Understood? So this is how very simple way of finding the time period. Clear? So remember that particular point. So whenever the signal given on sinusoidal or otherwise cosinusoidal, then that must be equivalent, that we have to equal to with the standard form of the nature of the signal, either of sinusoidal signal or cosinusoidal signal. Then if you equate both, then from that simply you can get the time period. Clear? I think you understood this very well. So with this I finish off this presentation, and we will see some more examples in the subsequent presentations. Okay, thank you. See you.